Um, I do have a couple of questions that I put up here because I wanted to wait for more people to show up. Because I've been grading the homework and it looks like I think a lot of people are going to have these questions. But before I get into those two things, anybody else have anything specific or general from the homework to ask? Anybody?
I have a question about 5.2. Can we go back to 5.2 real quick?
Yeah.
It's number 74K.
Let's see if that's related to. Oh, yeah, that is related. So, all right.
Okay, we can wait, I guess.
Yeah, I'm going to get to that because if you know how to calculate percentiles in a uniform distribution, you will know how to find the upper quarter. Because what quartile does the upper quarter relate to? If I say the up, yeah, 75th percentile. So the third quartile, yeah. So if you know how to calculate percentiles in uniform, you can answer that question, bam. You just got to find the 75th. So let's do that. Let's do an example of a uniform distribution and we'll just figure out some percentiles. Cooperate. All right, let's see. So I am going to make up. Well, dude, what's wrong with you? There you go. Let's hold you close. All right, that's good. Oh, my room is just tilted. Okay. So I'm going to create a uniform distribution. I'm going to say it's going to be uniform from 11 to 23. Why not? I like it. So it's going to look like this. How tall will it be? What's the height going to be? Oh shit. Let's see if I can get it to line up. That's a little better.
1/12?
1/12, yeah. So this is 12 wide. This is 12, and the whole area's got to be 1, so I got to make this 1/12. Now, real quick, if I had a die that had 20 sides to it, and it's a normal, nobody's weighted the die, how likely is it to get any number on the die? To get each, how likely is it to get a 7 if it's 20-sided die?
0.
All right, let's, no.
One
In this
out of
case,
20.
yeah, 1 out of 20. So it's only 20 sides. It's not a marble with an infinite number of sides or something. So does that make sense? That's a discrete thing. So why am I saying this? Because we already know how to, we should be cool with this 1/12 idea because there's a 12 here. Sort of like there's 20 sides on a die. So each one's got to be 1/20th. So this has a range of 12. So it's got to be 1/12. So the area is 1. Okay. How's that? Sorry. So what if I ask you this question? What's the probability? Actually, let's do this. Which order do I want to do this in? Sure, we'll do percentiles first. So let's say I want to find the 55th percentile. What does that mean? How far into the list of data do I want to go then? What does a 55th percentile mean?
It's like
Want to go with
50.
55% in, right?
Yeah, I want to go 55% of the way in. What's the mean of this, by the way? Can somebody tell me what the mean is?
$17.
17. You add these, divide by 2. And 17 would be the what percentile?
50th?
50th percentile. Okay, so I know the answer to this should be a little above 17 because it's supposed to have 55% below it, not just 50%. Is that all right? Okay. So help me out here. So if I want to go 55% of the way in, and how long is it all the way?
12.
12. And I want to go 55% of that distance in. So it would take 55% of
12.
12. Oh, I got. And then what is that? I believe it's 6.6.
Yes.
Yeah. Now that's not your answer. Because where does my distribution start?
11.
11. And how far from that am I supposed to go in? That much. So I take 11 plus 6.6, and I end up at 17.6. Why does that make sense? 17 is the mean. It would have been the 50th percentile. 55th should be a little above 17. Do you see how, does that make sense? So the idea of a percentile doesn't change. I'm supposed to go 55% of the way in. So I do exactly, I go 55% of the way in, and that number is not the answer. There's two steps like there was before. Then I have to go then I have to actually go that far in from 11, go that far in. That's exactly how you handle every percentile question. So if I wanted to know the top quarter, get out of there. We do this a different color. Top quarter. What the hell does that mean? So I've already asked a few people that question. What does that mean?
The 75th percentile.
Yeah, so it should be up here somewhere. It should definitely be closer to 23 now. So I want to find P75. So I would take 75% of 12, which is beautiful because it's 3/4 of 12 is 9. Is that all right? Go 75% of the distance. That'll be 9. So now I do 11 plus 9 and I get 20. That'll be P75, which makes sense. It's a little further in now. It's closer to 23. That is 75% of the way in. That's where the top quarter starts.
Thank you.
You're welcome. Somebody's giving me the party emoji. I like that.
I have
Okay.
a question.
Yes.
If the data started at 0, like if it started at 0 and you got them and you got 6.6, would 6.6 then be the answer and not
0 plus 6.6, which would just be 6.6. Yep.
okay. Thank you.
You're welcome. All right, so let's do the other. Is that okay for percentiles and quartiles? So that shows up in a couple places, I think, in the homework, that kind of question. Let's do the given one. I'm going to erase these.
Real fast, how did you find the mean?
Oh, so even without knowing the formula, holy macaroni, wait a minute. Even if I didn't know the formula, I'm hoping it makes sense that the mean of this, hello, excuse me while I break down. The mean of this should be the mean of these, right in the middle. So you just add these, divide by 2. So the formula officially is A plus B divided by 2.
Okay, thank you.
And I want to show you guys something that you definitely should know about. This is a kick-ass thing. Now, obviously, everybody's reading the entire book, but in case you don't do that, there is a chapter review that has the big points to make. This also includes the mean and the standard deviation formula. See those? But they also have a formula review where you can just find the formulas really quickly. Okay. So I didn't really spend any time on this, but I did assign some homework problems with this because you should know how to plug B and A into this bad boy. If anybody wants to see the proof of this, I did it a while back. I can try to find it in my files, and I'll send it to you. It relies on some calculus, because I always have people say, "Where's the 12 come from?" And then I'm like, "Well, you just got to see the derivation. You got to see how it's made." Okay. Oh, we got a bird over there. I see. I was trying to figure out what that was. All right. So let's do this problem. So what if I said, what's the probability? Are you working? Are you working? Sort of. What's the probability that X is less than 18, given that X is greater than 13? Yeah. I was going to show you both ways, but the second way is so gross, I'm not even going to show it to you. Screw it. Some of you guys did the second way. That's, if you want to do it that way. So what do I mean? So I really want this to make sense. This picture cannot change just because I ask a question. This is the picture for this whole problem. Whatever questions I ask, this is what the picture looks like. So if I ask another question, I find another area inside of here. So that height cannot change unless I'm given more information. So I know now that X is greater than 13. What's going to change in my picture then? Can it start and end at the same places? Where would my picture start now if I'm given that X is greater than 13?
13.
It would start at 13. So I can redraw the picture, because now this changes the situation. So it doesn't start at 11, it starts at 13 and goes to 23 now. So how tall will it be now?
110.
110. So do you remember how givens, and I have a given situation, that's the only time what could change the denominator, because I can throw some information out. So what I've done is I've effectively taken this piece and I've thrown it out. Chop, get out of here, because I'm given that it's greater than 13. So now the denominators will change. They will now be 10. So now if I look at my new picture, where's less than 18? And now I find that area. So that is the best way to handle uniform distributions given probabilities. Redraw the picture. So now this probability is going to be 5 out of 10, 50%. Because now 18 is the mean. So why did I draw the picture like this to begin with? Because I was given the information that it started at 11 and it went to 23. This problem says, I meant to say it starts at 13. So I redraw it. Does that make sense? So I've changed. Once I get more information, I can change things a bit, just like we did before. I can throw some stuff out. So I actually physically, I want some cake now, because I keep thinking in my brain, I cut this piece of the cake off and ate it. So now there's less cake. So now this is going to be smaller, actually bigger, but smaller denominator on my numerator.
If we weren't to redraw it and all that, can you show us how we do it the other way?
Oh, okay. So the other way to do this really kind of sucks. So because what's the formula for probability of A given B? It's probably A and B over the probability of B. So you'd have to figure out, let me see if I need some room here. So you would have to do the probability that it's, now watch this. This is kind of nice. It's got to be less than 18 and greater than 13. So you have to figure out this probability here, which is easy, over the probability of the given, the probability X greater than 13. So this is not that gross, but That's the thing you had to realize is the and makes it become this. It's got to be this and this, which makes it become, it's got to be greater than 13 and less than 18. So now you can use the original picture and calculate those things, and you'll get the same answer. Let's verify. 13 to 18 would be 5 times 1/12. And greater than 13 would be 10 times 1/12. The 12s cancel, you get 5 tenths, so you get 50%, just like we did earlier. So you can do it either way, either way. I like just redrawing the picture. It makes more sense to me, but that's just me. Anything else from homework stuff? Or anything else about this? I see.
Just wait, when you did it the second way, how did you get the fractions for like,
The probability that 13 is from 13 to 18 would be, draw this better, that area, which is 5 times 1/12.
oh, okay, got it.
And then greater than 13 would be 13 to 23 is 10/12. Yeah, and I still get 5 tenths, which is what we got earlier.
Okay, I
Doing it by
understand.
drawing it, yeah, I like it.
Thank you.
You're welcome.
Can we go into the book and look at a specific problem then?
Okay.
74.
So part I.
Yes.
Yeah. So
Would we just redraw the picture or whatever, the graph from 12 to 28?
No. Because what is it you're given? What piece of that is it that you're given?
X is less than 28.
Beautiful. That's all you know. So now it's going to go from 1 to 28. Because it started at 1 before. And now I'm giving you the extra information. Oh, yeah, it's less than 28. So it doesn't go from 1 to 53. It now goes from 1 to 28.
Okay, thank you.
And then you just draw the area that relates to greater than 12 in that new picture. Find the area, you're done.
All right, thank you.
You're welcome. I personally love that way because it's exactly what given does. It chops off some of the stuff and throws it out. Right? If I said given a woman, I could throw out everybody else that's not a woman. If I said given a Republican, I can throw out all the other political parties and just have the Republicans left. And that's why the denominator changes. So the height changing is exactly like the denominator changing. All right. Is that all right, guys? Are you okay? If those are the only problems that gave you trouble, you're doing pretty good. Those are the freakier problems. I agree. All right. Anything else before we get back into where we left off? Am I missing any chat?
So for I, the new denominator would become 27.
Yes.
Okay.
I love it because now it goes from 1 to 28. Kick ass. Kick ass. I love it. Okay. Anything else, guys, from any homework stuff? Okay. All right. So let me stop sharing this. Let me remind you about where certain things are. So if you missed some of the, whoops, where do I want to go? Oh, I see. I got to do this first. There we go. So if you come in here to modules, just in case you weren't here last time, if you go down to unit 6, crazy enough because we're in chapter 6, go to normal distribution practice, and we actually did the first problem here last time. You guys remember that? So we're getting back into normal curves. By the way, there aren't any normal curves. I don't think there's any. Yeah, there's not any in chapter 5. So some people are doing some z-score stuff in chapter 5. No. They don't have anything to do with normal until we get to chapter 6. And this also, something else you want to get, I think in that same module should be z-scores. Oh yeah, you want these charts here. The negative z-scores and the positive z-scores. So let's do a quick review problem, just to make sure we all remember how the hell this works. Oh shit, there went everything. All right. Which means I got to change this. Sorry, hold on. Over there, you guys go over there. I can move my whole class with the click of a button. It's crazy. Here we go. So a quick, and the beautiful thing about this chart is it gives you some notes. You can only use this chart if you know it's what kind of distribution.
Normal.
Normal. I mean, the picture up top tells you. What is that number that you look up? If you look up a z-score, what's that number tell you? It tells you the area below the z-score, right? That's all the chart is made to do. That's why it's so short. That's why it's not more than just a front and back page. So let's try a problem out. Get over here. Come here. Just so we all remember how the hell this thing works. So what's the probability that I get a z-score less than, what do you got, Jeff? 1.08.
.8599.
All right, let me see. Hold on, sorry. So let's see, 1.0, and then, so 1.0, and then 0, 1, 2, 3, 4, 5, 6, 7, 8. So 8599, I like it. So the thing is, so obviously 0 is going to have 50% below it because 0 is right in the middle. So there is relatively little difference. I really want you guys to get this. There's actually relatively little difference between using this chart and finding areas of rectangles, right? The only difference is when I draw the shapes that correspond to the questions, I don't get rectangles. I get funky things. I get, what the hell is this thing? I don't know. I don't have a geometrical formula for this. But so these are the areas. If it was a big ass rectangle, I would be getting these numbers by finding the area. These numbers are finding the area of this weird ass shape. So I desperately want you to realize the answer to a probability question still equals the area if I have a picture of it where the whole area is 1, which is what this is. So this answer being 0.8599 or almost 86% visually makes sense because 1.08 would be over here. Bigger than 50%, and this is where most of the stuff is, so it should be pretty big. There's very little out here. Okay, how are we doing out there?
Can you
Yes.
over again how we would know whether to use a positive or negative z-scores?
Oh, so the reason I use positive is just because it's positive z-score.
Oh, okay.
That seems kind of silly, but so let me do a negative one. What's the probability that z is greater than negative 0.32? I don't know why I said it like that. So now I got to use the negative. Let me get rid of this circle. Go away. All right. So let me scroll down to the negative. Oh, scroll up to the negative. There it is. You're gonna have to trust me a little bit because it's gonna have to go off the page. Too bad. There we go. I think I can fit it. Oh man, no, my writing's on top of weird shit. Oh well, too bad. Greater than negative 0.32. So one thing I should be doing just to really hammer it home that it's important to do this, you really, really should be drawing these pictures. So what goes in the middle if it's z-scores I'm talking about? What's the middle of a z-score distribution known to be?
0.
0.
0.
Yes, thank you. And there, where's negative 0.32?
On the left.
Yes. And of course, where's the area that this question's asking me about?
Left.
Which, sorry?
Area to the left.
It says greater than.
Right.
So I don't know if you guys are worried. This is going to tell me area to the left. So I'm going to have to do 1 minus. It's that same idea of if I find the opposite probability, I got to do 1 minus to find the actual thing I want. So when you look up negative 0.32 in the chart, I'm going to put the answer right here immediately. And I'm going to see, oh shit, I didn't get the answer yet. So what do you get when you look up negative 0.32?
0.3745.
Yeah, 0.3745. So that's not the answer, right? And I can tell because I was nice to myself. Oh, what's going on under? Since I was nice to myself, I could tell that I need this side. So how do I get the other side?
Subtract from
-1.
1 minus that, and I showed you the shortcut, I think, right? To make that 9, to make that 9, to make that 9, to make that 10. Yay. So if you draw the picture for yourself and shade in the area that represents the answer, you will make less silly mistakes. All right, let's try another one. Oh, I want to do, what do you get when you look up positive 0.32? Where are they? There they are. If you look at
0.6255.
yeah, you get the actual answer, right? Remember that was the shortcut? Do you guys understand why that works? Because the area that's up, all right, let me see. I gotta turn my pen back on. Make a different color. Let's make it green. The area that's above negative 0.32 has to be equal to the area that's below positive 0.32 because of symmetry. That's why that shortcut works. You never have to use it if you don't want to because it doesn't really save you that much time, right? So if you just want to use it and be all special, you can. If you don't care, then don't do it. Just do what we did here. No worries. So let me try another one like that. Here, you guys take a minute and figure out what the probability of z greater than 1.16. Jiminy Jeebus, wow.
0.
There's a lot going on. So the picture does a few things for me. The first thing it does is I already know the answer is going to be less than 50% because it's far away from what cuts it in half, right? Does that make sense? So I know if my answer is 72%, I have made a mistake. What do you guys get when you look up 1.16?
8770.
Yeah, make sure you get that. You got to let me know if you have questions because this chart is going to rule our freaking life for a while. So I desperately need you to get comfortable with it. You're not going to be comfortable yet. We just started using this thing, but let me know if you have questions about anything about this chart. So visually, I know now that that can't be the answer because I need this side. So of course, again, I just do 1 minus that. And I'll get 0.123. Neato. And real quick, do you see, when you do these kind of problems, please do box your answer off because you're going to have numbers all over the damn place. Please tell me what the answer is. That will help me out a lot. All right. So let's try a couple of freakier problems out. I'm going to erase all this stuff. Is that all right? You guys okay out there? All right. Bye, chicken scratch. There. So let me see. Let's use the negative chart for a bit. Should I? Screw the negative. We'll stay here. What if I ask you, what is the, oh shit, am I still sharing? All right, here we go. I forgot what question we're on. Oh well, I'll say it's 4. What's the probability that Z is between, oops, let's make it one positive, positive 1.04 and 1.56. I want to know what's the probability it's between 1.04 and 1.56. So go ahead and try to draw the picture, shade in the area. Let's see who remembers how the hell to do this. All right, so this is what your picture should look like. Right, they're both positive, so they should be up here on this side. You don't have to give them a face. It's all right. Now, who remembers how to do this problem? What are you guys, everybody's doing something, that's neat. What are you guys doing out there?
You find both z-scores.
Good. If I can find both areas, so if I find the area below 1.56, that is way more than I want. Right, but what is that area? 1.56.
0.9406.
9406, I like it. So that's 0.9406. How's everybody doing out there? You guys all right? Now I really want this to make just like crazy amounts of sense. That is way too much. I just want this area, right? So if I find this area, I could subtract it from this area and I'm left with what I want. That physically makes sense. Visually, physically. So when you look up 1.04, what do you get?
0.8508.
8508, I like it. And now if I subtract these two, I'll get the answer. All right, come on, pen. All right. What is it? 0898?
Yes.
Yes? Cool, man. I just guessed. Yay. So it's about 9% almost in between those two. So this is not satisfying on one level. This doesn't mean shit to me, right? I'm sure some of you guys are like, all right, what the shit does this mean? Well, if these were heights, then I would know that 9% of people are between those heights, whatever the heights those represent. But these are z-scores, which are not physical measurements. Z-scores are just the number of standard deviations. So if I have a problem that's just z-scores, I've lost all information about what they represented. So these kind of problems are just simply, can you use the frickin' chart? That's what these problems are. So we were about to get into, what do you call it? Using real life situation and finding out probabilities. I want to do one more problem from here though, before I get back to that, because there is a weird thing. Does somebody remember how to find something like P what, Jeff? Let's say, I want to get one that's not too freaky. Sure, P89. What in the hell does that mean? What the hell is that? I'm really curious. I gotta remember.
I think you turned it into a. Actually, don't you have to look for a number closest to that?
Closest to what? Where? Why?
Closest to 89. 0.89.
There you go, 0.89, because what does 89 represent? There you go. John's got it. So if I drew this picture, and by the way, all these problems we're doing are assuming a normal curve, obviously, right? So if I draw a normal curve, where would 89% have to go? Well, 0 would be the 50th. Yeah, so I think I heard it.
Before the 0.
No, because then it have less below it. It's got to have 89% of the picture below it. So it'd have to be over here.
Yeah.
Yeah. So that's 89% of the pictures below it. I'm trying to figure out what z-score that is. So if I start at 0, if I start going up from 0, I start getting more and more area as I go up from 0. So for example, at 1.00, I have 84% below. So I'm getting close. 1 is the 84th percentile roughly. Do you guys see that? Because the z-score of 1 has 84% below it. So it's just like you said, you want to get as close as you can to 89. So where the shit is 89? What's the closest you can get to 89?
0.8907.
Yeah. Why is it not this lucky number here?
The difference is more.
Yeah, this is 12 away and this is only 7 away. So what z-score is this? I just have to look out, right? What z-score is that? It's going to be 1.23. Oh, that's neat. I like that. I can't take credit for that. I wasn't thinking that far ahead. Yeah, there you go, Albert. I like it. Albert beat me to it. So if I find the closest thing, how do I convert a percentage back to a z-score? Well, I just look back out. 1.23. That must be the z-score that has 89% below it. So it's the exact reverse of what we did up here. Here I knew the z-scores. I looked them up out here and I looked inside to find the area. Here I know the area. I look inside and then I look out to find the z-score. Oh, shit. So let me push this one step further like I always do, Jeff, why? So let me give you a little more information. What if, for this problem here, I happened to know that the mean is 40 and the standard deviation is 3.3. Why did I pick 3? Good Lord, Jeff, you know better. 3.3. Can somebody tell me, and let's say this is age of people somewhere. Can somebody tell me what age this represents? Oh, neat. There's an algebraic way you can do it. There is a, can you remember what a z-score is supposed to mean way to do it?
do you add 40 plus 3.3 times 1.23?
Exactly. Now, why the shit did you do that? Because the z-score tells you what?
How many standard deviations away it is from the mean?
Yes. So it's positive 1.23. That means it's 1.23 of these away from the mean. Above even is better since it's positive. Now, I put that in the calculator. I almost don't give a shit what the answer is, to be honest, because you just put the old calculator and get a number. Who cares? So whatever the hell you get there, 40, whatever. What's a little more interesting, can somebody just tell me that so that I can just move past this? What is that?
44.059.
Oh, 4.34059?
44.0.
Oh, 44. That makes sense, Jeff. 34059, blah, blah, blah. That? Okay. Blah, 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 blah. Okay, now watch. So I really want to show you where the hell this thing came from. So this is x equals this. This is figuring out what the actual age is. Let me do it up on the board. I'm getting tired of doing it on this damn thing. Let me know when you guys are done copying down my little Christmas themed scribble. Using forest green and blood red. I like it. Sorry. I'm going to clear all that. It's going to go away. Actually, I'm going to do even more than that. I'm going to stop sharing. Do I want to? Ah, shit. Actually, I probably should do it here. Damn it. I was so excited to not do it here. I'm going to erase this first problem, I think. I got to do it up here so I can really show you where things are coming from. Man, shit. All right, let me see. All right, there we go. Some space. All right, here's the z-score formula. Where is it? There it is. So if I know the data point and I know these guys, I can solve for the z-score. Down here, I knew the z-score. I needed to solve for x. So can you algebraically, please, solve this for x? We actually did this the first day. I don't know if you guys remember. We had that little warm-up sheet we did, and this was one of the problems. You had to solve for x.
X equals mu plus z sigma.
Wait. I'm almost never as interested in the result as I am in how to get there. So what's the first step?
Plug everything.
What do I need? What's the worst part about this equation? What do I want to kill first?
The standard deviation.
Yes. So I'm gonna, I don't know why his hat's so long. So if I kill that standard deviation, I get z sigma equals x minus the mean. My poor little sigma dude. Oh well, I'm gonna deal with it. And of course, how do I get the x? I just have to
Add the mean.
add the mean. So I end up with mu plus z sigma. And look at what we did down here. 40 was the mean, right? Plus 3.3 was the standard deviation times 1.23 was the z-score. So that is a formula that we did not need when I did this, but now you can use the formula directly. So this is just the z-score formula solved for x instead. That's all it is. I like it. So now, if you are able to go to Canvas, I don't know if anybody printed this out last time, that worksheet that we started on, we're going to finish it. Finish it. So let me clear this stuff. So you definitely want to write that bad boy down, that formula down. That's key. So I'm going to clear all this stuff. It's going to go away. I don't see anybody yelling at me, so I'm going to do it. It's gone. So So if you will go to Canvas and grab this worksheet, or just find out where the hell you put it. This one. Oh man, Jeff. I know. Let's put it over there. There we go. Get up there. Don't be freaky. There we go. Okay. This guy. So we did this part last time. We even talked about 2a a little bit. So the first step in these problems is to convert this to a z-score. So just to make sure you guys really get the idea, what would go in the middle of this first one? Let's just redo this problem because we did it last time, but what goes right in the middle here?
33.74.
Good. Don't tell me no 0 because this ain't z-scores. 33.74 is the mean of the time. So then where's 27.2? That's the data point I'm curious about.
To the left.
Yes. Got a special place in my heart for the students to just kind of throw these numbers down there, but they have to be in order. All right. And then it says less than, which kicks ass, because I'm not going to have to do 1 minus or anything. So what we did last time was we realized, okay, I've got to make this into a z-score. So what z-score does this guy become? What does he become?
0.
0. So now I'm going to try to figure out what's this guy become. So I just have to do the old z-score formula. My data point minus the mean divided by standard deviation, which is 8.63. So all I'm doing, I really want you guys, if I know relatively how far away this value is, the chart will tell me, well, if you go that far away, you'll have this area left below you, which is equal to the probability. So that's why it's so important to know if something's normally distributed or not, because if it is, I've got a whole list of all the answers. Crazy. All right. So go ahead. What do you guys get for this? This is where you got to really be careful. Say again?
Negative 0.76.
Negative 0.76. It sounds plausible. Plasma. Is that what you get? Anybody else got that same thing?
I did.
Okay. So now it becomes a problem where I just look at that z-score and get the answer and I'm done. So if I change that to a z-score, I can then look that up on the chart because I know it's normal. I can get the answer and I'm done because that's the area it wants. It wants the area below. Oh, let's see. Where did I put that? Sorry, I'm tuckered out. Where are you? Shazbot. I've lost everything. Oh no. Why am I not able to do shit? There it is. If I do that, what do you guys see? Are you guys, let me move this over here. So hopefully you guys have a way to access the z-score chart. Whoa, what happened to you? It's a very weird technology day over here. All right. So if you look up negative 0.76 on the z-score chart, what do you guys get?
Wait, 2236.
2236. Yes, I like it. Bring you guys back. There you go. So, oh crap. Let me do this. So many little buttons to push. I hate it. All right. 2236. So about a 22% chance that it took a student less than this many minutes a week to find a parking space at the college. Back in the day when we did that, we parked at this building that had seats in some of the rooms and like whiteboards in there. It's crazy. It was a while back, kids, in the before times. So what I want you to do is finish this up. Do the rest of it. I'll just sit here and not do anything. Sounds about right. Let me stop recording for a while. Oops. That sucks. All the stuff I wrote is gone. Oh, well. So like somebody just said, it's got to be down here for the 14th percentile because it's only supposed to have 14% in it. It's got to be down here somewhere because there would be 50% below the mean. So can you find the z-score that relates to for 0.14 below it?
Negative 1.08.
0.5557.
Why is so many people so soft? 5508 or something? No, that sounds too big.
Negative 1.08.
Oh, okay. That's a possibility. Did somebody else get that same thing?
I did.
Okay. And what was the area that was closest to 0.14? You didn't find exactly 0.14, did you? What'd you find?
1492.
0.1401.
1401, yeah.
Negative.
Well, no, that won't be negative. That's just an area. Can't be negative. So that was the closest you can get to 14%, which is pretty damn close, right? Does everybody agree with that? And then when you look out, so you found 0.14, Jeff, 1401, and then you have to look out to see what the z-score is. So then you get the negative 1.08. Oh, that's the end of the thing. Okay. Let me stop for a minute. Is everybody cool with that? Is everybody able to see that on your own on the z-score chart? The closest I get to 14% is 1401. And that's, if I look out, that's a negative 108. But I need a time. That's not a time. I didn't find a parking spot a minute before I got there. How do I convert that back into a time? That's when we use this bad boy. Go ahead. So if I know a z-score and I need to convert that back into a physical measurement, in this case, time, that's what I use. I use the backwards formula. So then I got, what was the mean? 33.74. Now I'm going to go down 1.08 steps. That was 8.63. Kabam. So again, if they give me a percentage to start with, I've got to work backwards. I got to work my way back to a z-score. And then if the problem is a physical measurement like time or something, I have to then convert it back to what's called a raw score, the X score. Why are so many people leaving? What's happening? Oh, somebody keeps leaving and coming back. So whatever the hell this is.
24.42.
24.42. Ooh, look at that. It's palindromic. All right. 24.42 what?
Minutes.
Minutes.
There we go. That's got to be part of the answer. Yes. All right. So while you guys were working on this together, I created the practice quiz. I'm going to put it up on Canvas as soon as class is over. And then I'm going to try to make a solutions video for it sometime tomorrow. So you can look at it or not. It's up to you. It's not an assignment. It'll just be, if you want to look at it to help you out to get ready for the quiz, you can. If you don't have to. Any questions? I think I'm going to call class right there. Why not? That's pretty good. Do you guys have any questions?
So the quiz is next Monday.
Say again, sorry.
So the quiz is next Monday?
Yes.
Okay.
And it's chapter 5, chapter 6, just like it says on the homework sheet. Yep. Everybody else, you guys all right? Any questions? Anybody need to hang out?
I'm still just a little bit confused on how to like go about doing the homework for like 5.1 and 5.2. I think maybe I just got a little lost during that lesson. Do you have the like our class recorded so I can watch that?
Yeah, it's up on YouTube.
Okay.
Let me make, it should be up on YouTube. So let's see. I'm trying to start, well, let's see. Did I manage to do it? No. But yeah, the one from, what was the last class? The 30th? Yeah, the 30th, it's up there. And the link is up on Canvas to the, on YouTube.
Okay, thank you.
You're welcome. Everybody else okay? I'm gonna head out if I don't see any questions.
I have a question for number 82 for the homework 5.2. Can we go just quickly over to 8? A? To letter A? Oh, sorry, letter I.
Let me catch up to you. So number 82,
For homework 5.2.
part I. Oh, okay. So what's troubling you on this guy?
I think I put it wrong. Instead of putting 25 and then 55, I put 25 and 40. So I did it wrong when I
So,
was trying to find.
so this is kind of related to if I rolled a die and I said, what's the probability I got anywhere from a 2 to a 9? Well, that's kind of silly because the highest I can get is a 6, right?
Yeah.
But I only worry about the parts that actually have probabilities. It's a 2, 3, 4, 5, 6, and I can figure out that probability, right? So this one, the highest it goes is 45. So when it says 25 less than X less than 55, I just don't pay attention to 45 to 55. Another way to look at this problem is if I roll a die, what's the probability I get between a 0 and a 7?
0.
No.
1. 1.
How do you mean? Give it to me as a percentage. So what are the possibilities for rolling a die? You can get 1, 2, 3, 4, 5, 6, right?
Huh?
When I roll a die, you can get 1, 2, 3, 4, 5, 6. Right? So what's probably I get between a 0 and a 7?
0.
No. If the probability of that is 0, that means the probability of not between 0 and 7 is 100%. But don't they have to occur between 0 and 7? So don't listen. Let me see. How do I say this? What's the probability that somebody is in between -5 and 800 feet tall? 100%, because there's nobody
100%?
that's outside of there, right? Does that make sense? So
Yes.
this question says what's probably between 25 and 55, but where does everything go between 25 and 45?
And 45.
So does this leave anybody out?
No.
So what's probably I get something from here in between those? It's got to be 100%.
100%. Yeah. Oh, okay.
Because it contains all of them. Yeah.
Okay.
Just
Thank
because
you.
it goes over doesn't mean it changes anything. It's still, that catches everybody. Yeah. Oh,
Okay. That makes sense. Thank you.
I like it. Thanks, guys. Anybody else? Everybody else okay?
I have a question for my quiz.
Sure. What's up?
On question number 1A, it was about verify that it is a valid probability distribution.
And let's see, let me look up here real quick. Where are you? Oh, okay. There you are. Yeah, so you say you get 1 and you don't.
Yeah, I wrote that because when we were in class, you told us that it is a valid probability distribution if you add all the probabilities and get 1. But
That's right.
since I got 1.001, I didn't know how or what should I write there.
Yeah, and I told you guys this was going to happen because
Yeah.
I said I was going to make it something not 1. And all you have to say is, don't say it is 1 when it isn't,
Oh,
but
okay.
say that it is 1.0001, which is close enough to 1.
Oh, okay. Okay.
Yeah, it's only off because of rounding. Yeah.
Okay. Thank you.
Welcome.
Bye.
See you. All right, I'm gonna head out. I will see you guys later. Take care.